introduce Aaron Williams from MapT Technologies. Aaron runs MapT's global community, including the open source project and outreach to developers. He's responsible for MapT's developer, user, and open source communities, and has more than 2 decades of previous success building ecosystems around some of software's most familiar platforms. He will be presenting a talk titled The Need for Speed, How the Auto Industry Accelerates Machine Learning with Visual Analytics. Please join me in welcoming Aaron.
Thank you. I'm going to try and do the talk from here, so I just want to make sure everybody in the back can hear me. All good? Especially you in the very, very back. Double thumbs. Okay, that's a good sign. No. I'm gonna yell to him. Yeah. If it ever gets bad, you're gonna give me one of these, okay? Okay. All right. Thanks, everybody. Great to see everybody. Everybody had a good lunch? Yeah. Everybody's coming back full of energy, right? Full of sugar, ready for a good presentation. I'm going to try and make this, or I'm open to making this as interactive as you all want it to be. So if you have any questions as I'm going through things, or if anything doesn't make any sense, don't be shy. I can't guarantee I'll have time to be able to like go super deep on any one particular topic, but at least we can follow up afterwards if I don't have time. And with that, I think we can get started. Who here has heard of MapD? Oh, not very many. Okay, good. That's great. And second question, who here is, I'm going to ask a few different job titles. So data analyst, very few. Data scientist, student. Okay, good. A fair number of students. That's sort of what I remember from last time. I spoke here I spoke at Big Data LA maybe 2 years ago, or 3 years ago, and really enjoyed it because it was such a sort of vibrant group of people. So looking forward to this one again. All right, here's all of my contact information. The slides you're going to see today are already uploaded onto SpeakerDeck, so you don't have to feel like you need to take pictures of all the slides. Of course, if you want to take pictures of me and the slides, I'll be happy to make sure I'm in the frame. But feel free to reach out to me as well if you have any questions or any ideas after the presentation. I'm happy to stay connected to the folks that are interested in what we're up to. All right, who knows this guy? About half? Only about half? Come on. Okay, there. Okay, now people are actually raising their hands. Satya Nadella, right? Our good friend, Satya Nadella, CEO of Microsoft. Right, exactly. I love this quote for 2 reasons. One, well, it's not a terribly unique quote. You've seen a lot of people actually give a quote similar to this. It's software is eating the world. That's the kind of way that a lot of people boil it down. Every company is becoming a software company, and they're not just using software as a way of making themselves better. They're actually using it as a competitive weapon. The success of the software that you have in your company that you're building makes a difference in terms of how you compete with the other companies in your market. So it's not just good enough to have great products anymore. Now you've got to have great software to run your business. And I would add that that applies to data as well. Now we're in a world where data and sort of how we use data becomes a competitive weapon. And so this talk is really about 2 things. One, I want to talk a little bit about where we see that competitive weapon going, how a company like Volkswagen is using that data as a competitive weapon. So I'll use them as an example. But I'm also going to talk just generally about some of the trends in the industry around the use of GPUs and the use of machine learning with GPUs for large data and big data scale problems. There's only one small change I'd make to this quote. It's not a question of it will happen. It already has happened. It's done. It's over. Software has already eaten the world. But that's good for us, right? So no complaints. A quick note on the evolution of this competitive weapon that I keep talking about. And this is, I'm going to put this in the context of Volkswagen, who's the partner that I'm going to talk about and use as a use case for most of my talk today. Volkswagen has a separate unit within Volkswagen called their Data Lab. And that Data Lab has been, for the last 7, 8 years, collecting data. Of course, they have a ton of data. They have telemetrics data from their cars. They have data about their manufacturing processes, and then all the other standard sort of internal data that you have in a large company. So they've done a good job of collecting it. They've got warehouse and lake after lake of data. What they wanted to do was make it actionable. Anybody else in here wear a Fitbit? Yeah? So it surprised me when I first started wearing a Fitbit only a few months ago, how simple data, like the number of steps I took and the number of stairs I climbed, actually changed the way I act. Of course, you know, the number of steps I took had always been a piece of data that was there. I just didn't know it. It wasn't available to me. It wasn't actionable by me. But now that it's actionable, now that I have it at my fingertips, it changes the way I act. And this is true for most Fitbit wearers. I think this is true for business data as well. If you can make that data actionable, if you can put it into the hands of decision makers, then it becomes valuable data, not just collected data. And then last but not least, it's about making it predictive. So no surprise here. I bet that's probably what has drawn most of you to this event in the first place. There's a ton of talks around ML and AI, and we'll talk a little bit about how you can use that with a GPU database in a minute. So what is MapD? MapD is a database, a SQL database, built from the ground up to run on GPUs instead of CPUs. Anybody know why we would want to run on GPUs instead of CPUs? Faster? Yeah, why is it faster? Yeah, parallel, exactly. Why else? Faster memory. Oh, sorry. Were you going to say faster memory? Beautiful. See, that's even smarter than I could say it. So yes, exactly. GPUs have two benefits over CPUs. One, they have orders of magnitude more cores, which means they can run orders of magnitude more instructions in parallel at once. That's great for doing things like graphics, because graphics is really just matrix math. It also turns out it's great for doing things like SQL queries. We can take SQL queries, break them down into a bunch of small instructions, and run them across these parallel cores, and actually take full advantage of that massive parallelization. The second benefit is the memory throughput. The memory on a GPU is actually built into the chip. So when you buy a GPU, you're not just buying a chip, you're buying a chip with memory already attached to it, and that memory is super lightning fast. Now, that's great because it helps us do more and more, have more and more throughput of our data to be computed with. But it also means that if you want more memory, you have to buy more chips. There's no way to just sort of add memory to your system. You have to actually buy more GPUs that has more memory associated to it. We'll talk a little bit about the impact of that when it comes to doing big data analytics in a minute. But those are the two reasons why we looked at GPUs and said, boy, this is an opportunity for us to make a pretty big game change in how people look at analytics. This is what the sort of MapD architecture looks like. Down here at the bottom is MapD core. This is our core database. This is the SQL engine. This is what is 100% open source. You can go to GitHub today, download and use the core database, the SQL engine, for free. Would love to have people that are really hardcore interested in CUDA coding and doing parallel compute using GPUs to come and help us in the project if you're interested. But this is kind of this is our bread and butter. This is what we were built on. On top of that, we've built a rendering engine which takes full advantage of the GPU. I'll talk a little bit more about how that works when I get into the demo. And then on top of that, we've built this immerse platform, which enables you to build dashboards and do BI on top of that data. It knows how to take full advantage of those GPUs, and that's why this is really kind of one integrated stack for us when we think about how we deploy this out to our customers. All of these pieces of the stack understand that they're running on GPUs and they can take advantage of those GPUs, and I'll show you what that means when we get into the demo. Now, a lot of people say, yes, but I really do not want to move all the data I have over into GPUs. Okay, great. Most of our customers don't actually put all of their data into MapD. They keep the data where it already lives. So on the left-hand side, there's ways to bring data into MapD. Usually, MapD is sort of an accelerator that lives alongside whatever data warehouse or data lake you already have. So we can stream data in, we can bring data in through any of those APIs that you see. Once it gets in, then you can either visualize it using our Immerse platform, or we have APIs for building custom applications, for doing BI and GIS with other platforms, and also for doing machine learning and other sort of data science things. So we have PyMapD, for instance, for being able to write Python scripts directly to the database. And I'll show you what that looks like in a minute. So I like to start here only because it helps to contextualize what it is you're going to be seeing in the demos. But next, I'm going to jump in and actually show you a few demos of how this thing works, or what it looks like when it works. All right. That's not the first one. This is the first one. So this is 12 billion rows. You can see it maybe up here at the top. Up here, you can see 12 billion rows of data from the U.S. Coast Guard. Every ship in U.S. waters has to send a ping back to the Coast Guard about every half hour They have to say sort of who they are, where they're going. It's all the telematics data that you'd expect. So we've taken 12 billion rows of that, brought it into MapD, and now created some charts here to visualize that data. If I click on any one of these ship types, so let's just take the passenger ships. I click on passenger ships, you can see everything cross-filters very nicely across the various charts. But what actually happened there, that's the cool part. Each one of those charts sent a brute force SQL query back to our MapD server sitting in San Francisco, did a full brute force table scan across 12 billion rows, and returned the results back to the client in about 150 milliseconds to 300 milliseconds. So that was 4 brute force SQL queries across 12 billion rows. We have no indexing. We haven't done anything to the data ahead of time. It's all just the power of that parallelization of the GPUs and the super fast memory that makes it possible for us to run just lightning fast queries. And just to prove that there's nothing up my sleeve, I'll do a quick subset here just of what's happening down here in Southern California. So now I've added a new filter, right, saying just give me the points in this area. I'm down to just 39 million points from 12 billion points. And you can see how quickly that refreshed the entire screen. Again, hundreds of milliseconds for each chart to go back and do a full brute force query. Now this chart on the left-hand side is actually my favorite, because what we're doing there is we're taking the results of the query, which now I'm back to 630 million rows. I take the results of that query, I pass it back to the GPU, and I ask the GPU to render that image for me. So I'm not passing 630 million rows back to the client and expecting the client to do the rendering. It's all happening in the GPU. So what comes back to the client then is just a PNG. And then I place that PNG on top of a map. That gives me 2 benefits. One, of course, I don't have to send 630 million points back. But also, I'm taking full advantage of that GPU, and I'm not losing any fidelity. So if I roll over any one of these individual points, I can still get full data on each individual point. Now you might say, yes, Aaron, but there is no way you can put 630 million points in one PNG. Yes, true. So what you actually get back is a PNG, and you get back a metadata file that says, here's all the points, here's all the rows in your database that are associated with this pixel on the screen. Right now, when I hover over, it's just showing me the top one, but if I wanted to, I could get all of the, all the rows that were associated with that pixel. Now, this is true. This is true not just for these scatter plots on top of maps. We can also render all kinds of other complex analytics, complex visualizations on the back end, and just send to the front end the images needed for it. Sorry. Let me just show you one more quick thing with this data set. So if I look just at the passenger ships that are of a certain size, so I've just scrubbed over and said, give me the reasonably sized passenger ships. You can see the seasonality of it. It's obviously cruise ships, right? If I come down here and scrub again and I say, okay, give me just the ones that happen in the winter, you can see there's a lot of traffic out to Hawaii in the winter. If I then scrub that over and say, well, what's happening in the summer? A lot of those cruise ships are going up to Alaska then in the summer. Now, this isn't some crazy insight, right? But the point is, when you take data like this that's of this size, you make it possible for an analyst with a simple dashboard like this to be able to go from 12 billion rows down to the 4 million rows they care about, be able to interact with that data to find these kinds of interesting anomalies in the data. You're suddenly empowering your team to think about data completely differently. It's no longer something that you query and wait for a response to come back and then somehow react to that query. Now it becomes something that you can put out into the hands of all of your business teams. Sorry, folks. And this is exactly what we see at some of our customers, like Verizon. They used to have a data science team that was really focused on answering questions back and forth. You'd send them a query, they would send you a report that had an answer in it, and it would take days, sometimes weeks, to get that answer back. Could you give me some water? Thanks. No, I think she's going to get me some water. I don't know what happened. it would take them a long time to get a response back from that data science team. Now, instead, they've said, hey, data science team, don't be responsible for answering these questions. Be responsible for making sure the data is available in the fingertips of the analysts out in the business teams, and let them answer these hard questions by giving them the right interface and the right experience to do it. And this kind of an interface, this kind of an experience makes that possible. Oh, yeah? Oh, thank you so much. Sorry, folks. Thank you. This makes that possible. I think that's all I wanted to say on this. I'm going to show you one more quick demo, just because it's my favorite demo. That's our tweet map. Oh, by the way, both these demos that I'm showing are available publicly on our website. If you want to go play with them for yourself, you can go to mapd.com, go to our interactive demos. You can be a boat captain and play with 12 billion rows of boat data till you're blue in the face. And you'll see the same interactive experience with that data. Second demo. This is our tweet map demo. This is the most recent, roughly 400 million tweets that came out of Twitter that included a location tag. So it's not all of the 400 million tweets, it's just the ones that included a location tag. We've mapped them all on a map. We've put the top hashtags on the side there. We've put all the most popular languages down at the bottom. This is an example of a custom application that we've built on top of MapD's core database. So what I was showing you before, oh, thank you so much, Dipti. Thank you. Whereas what I was showing you before was Immerse, our product. Now I'm showing you how we're using the APIs in the database to be able to build a custom application or a custom interface. But it still has all the same benefits of what I was showing you before. So, for instance, still has the ability to roll over and see any individual tweet. Oh, I get really scared when I do this, because you never know what's going to come up. Okay, and I got to reload. Sorry, I didn't reload. I didn't reload when I opened my laptop. That's me. That's just bad demo etiquette. Please don't be bad. Okay, that's not so bad. You'd be surprised how often I get a tweet that I really wish I didn't get. So I play a little Twitter roulette every time I do one of these demos. So every single tweet, all 390 million tweets are available here in this interface. I can also say, just give me the French language tweets, for instance, which is always kind of fun. Always surprises me a little bit, like how pervasive languages are around the world. Like I expected to see it in France, of course, and I expected, I guess, to see it in Montreal, but wasn't so sure I would see French quite so pervasively around the world. And if you can see, especially y'all in the front row, can probably see these little orange dots in the middle of the ocean, right? First time I saw that, I freaked the hell out. I was like, there is somebody lost in the ocean tweeting French tweets out. I was ready to call the Coast Guard. So I rolled over it. I was like, okay, what is that actually? You roll over it, and it's this weird account called Guguns Lols, who tweets out these like super bizarre encoded messages and just puts a random location tag on the message. And if you go to his website, or her website, I don't know, you go to their website and you actually see like the details of this stupid encoded message that they have, and it's like super intricate and I guess has like a whole backstory to it. Thank goodness it's not some French guy sitting in the middle of the ocean. And if I say, okay, just give me his tweets, or her tweets, you'll see, yeah, it's a perfect distribution, no particular location. And by the way, not just in French. If I take off the French filter, boom, you'll see it like show up in all the different languages. It tweets a random language, a random location, and some weird encoded message. Feels like I'm back watching the TV show Lost, for anybody that's old enough to have enjoyed Lost back in the day. So again, what I'm showing here is sort of some of these weird patterns and anomalies that you can find when you have data that becomes interactive. I'm showing it here in the case of a completely custom application that we've built that just runs on top of the database. All the code for this is public. It's available as a public open source repo. So you can go in and see how we're using the APIs for connecting to the database, for doing the rendering, for doing the charting, everything that it takes to build this application. We had an intern build it actually last summer, so not terribly complicated to build either. So anyway, those are my sort of two initial demos, just to give you a sense of kind of what the problem set is that very large data, trying to make it agile, trying to make it interactive, trying to make it something that they could roll out in a much larger audience so that people can play with it and make decisions based on it. Does that make sense? Any questions on that before I move on? Yeah?
Can you run into a PDF quickly or in real time?
In theory. So we haven't written any extensions to be able to do that. But pulling the data out is so fast, you would spend all the time in that problem, in that pipeline would be solved just creating the PDF. So we haven't done it yet, but we'd love to work with somebody that wanted to do it because we just haven't done it. Most of what our customers are looking for is this kind of interactive experience. Okay, any other? Yeah, one more. How scalable is the, sorry, I missed the last part. Yeah, okay. So this example here is running on a single GPU. The example I showed before with 12 billion rows is running on a single box with 4 GPUs running in the box. So we can scale up to multiple GPUs in a single node, and we can scale up to multiple nodes. Some of our largest customers are running hundreds of billions of rows in a single database with full interactivity under 300, 500 millisecond time frame for SQL queries. And again, remember, we're not doing any indexing or anything with the data. It's all brute force queries. Yeah. We're going to talk about that in just a minute. Actually, let's go to that. That's a great question. So his question was, do I need all of the data to live inside GPU memory? It's like I asked you to ask that question. The short answer is no. When you bring your data into MapD, it actually starts down here in the storage layer. So it's going to start in your data lake, data warehouse, wherever you keep the data today. You'll bring it up into SSD, where you can have basically as much data as you want. Then we bring it up into CPU RAM first. There again, you can almost have as much data as you want in CPU memory. Only when you make your first query do we bring specific columns up into GPU memory. And we only bring the columns you're querying against up into GPU memory. So even for something very, very large where you may have 100 or 1,000 rows, or 1,000 columns, sorry, in your database, depending on how your queries are set up, you may only bring 4, 5, 6 of them up into GPU memory. So it may be a small fraction of the size of your database that ever lives inside GPU memory at once. Now, of course, you're still going to reach a maximum where you can no longer run a query. We can fall back to running the query on CPU memory, and I'll talk a little bit about how we do that in a minute. You're going to lose all the performance benefits, of course. You're not going to be able to run that in GPU memory, but it's possible. And then the other alternative, of course, is just go buy some more GPUs. I'll be happy to introduce you to my friends at NVIDIA, and they'll be happy to sell you as many GPUs as you'd like to buy. Or we have friends at Amazon and Google, and they have tons of GPUs just waiting for you to use. Does that answer?
Yeah, sort of. Does it do dynamic relocation of the data between memory and GPU, or you have to bring the data in GPU?
You don't have to worry about that at all. So it's all handled by the system. So if you want to go down and sort of monkey with the data, I'll show you kind of how you can do that a little bit later. But for the most part, for most of what our customers' use cases are, they'll just use something like PyMapD, open up some pandas, and start going. And the queries will just be lightning fast. Or they'll go create their front end and start doing queries through the connector back to the back end and bringing those visualizations back. And it just happens. MapD is set up to be able to manage that CPU and GPU memory most efficiently.
But the 100 milliseconds that you said is
GPU. Exactly. Yeah. Yeah. Talk more about that in just a second. So this is one of the things that makes our database kind of special. I told you at the beginning it was built from the ground up to run on GPUs. Well, part of that story is we understand how to manage the memory of the GPUs and the CPUs. And that's something that was not easy to do, but it's all open source. If you want to go take a look at it, you can go see out in the core database how it all works. Did anybody go to the Dremio talk earlier today where they were talking about LLVM? Yeah? So I didn't include the slide here because I didn't know if it was going to be relevant or not, but when he was talking about how LLVM is this technology that's used by database engines to be able to run really, really fast, to run queries really, really fast, compile them down to be as fast as possible, we use that. It's one of the differentiators, another one of the differentiators we have in our database is that we compile all of those queries down to be most efficiently run in CUDA code on the GPUs. The side benefit of that is we could also compile those same queries down to run on CPUs as well. So if you want to run MapD just on CPUs, I run it on my laptop as a Docker container all the time, just to be able to use the same interface, and then I deploy it out when I'm ready to go to scale to my instance that lives on GPUs, you can do that. You can also run queries that don't necessarily need the full speed of GPUs on the CPU if that's what you want to do. So we take full advantage of that, and LLVM is the technology that helps us do it, because we can compile those queries for GPU or for CPU. And of course, it'll enable us to compile it for whatever the next thing is, or whatever the next company that comes along with a fast GPU. One other thing that they talked about in that talk was Arrow. I'm going to talk a little bit about sort of what that's done for us as well. About a year ago, we created a initiative with NVIDIA and Anaconda and H2O and some other friends called Go AI, the GPU Open Analytics Initiative, that was designed to create a pointer inside GPU memory that we could pass around between all these applications. We got tired of loading the data up into GPU memory, doing our thing with it, and then when we wanted to pass it off to H2O, we had to bring it back down into CPU memory, pass it back, and have them load it up into their GPU memory so they could do what they wanted with it. So now, instead, we have this thing called the GPU data frame. It's based on Apache Arrow, and it enables you to pass that data around between these different applications seamlessly. I'll show you an example of it in just a second. We've got some code out there that you can use, and this is what Volkswagen was doing with us, was sort of taking advantage of this speed of passing data back and forth between a machine learning algorithm and a database and a visualization engine. The key is we want to keep everything in GPU memory for as long as we can, because that's where things are fast across all those different things: rendering, SQL queries, ML, all of it. All right. If you go look at PyMapD, that's our Python. That's our interface for Python to MapD. You can get started there. We have plenty of examples out there. And then if you go to GPU Open Analytics, PyGDF, those are both out on GitHub. That's where you can get examples for using the GDF, the GPU data frame, for connecting. I'm going to show you one other example, the one that we built for Volkswagen, in just a second. But that's sort of the baseline of where can you go get more information about those two technologies. So let me talk. Now I'm going to sort of shift gears a little bit, because I want to go a little bit more specific on what we did with Volkswagen. And I'm getting close on time, so I'm going to have to go a little bit faster. So here's what we see as being kind of or what we worked out with Volkswagen to be sort of a typical machine learning pipeline. Starting with data preparation, discovery, feature engineering, modeling, predicting, monitoring, and then evaluating. And each of these steps actually has a different set of personas at a company the size of Volkswagen that are kind of paying attention to or engaged in each of those steps. And this goes back to my point before about how this shift that we're making towards making data available, making it fast, making it interactive, also requires us to think about how different people are going to engage with the system. And that means it's not about providing one tool to rule them all. Each of these different sort of personas and each part of the life cycle has a different set of tools that are kind of native to those problems that you're trying to solve. And so part of what we've tried to do, and part of what we've worked out with Volkswagen, was sort of first cut at what might that look like if we were to make MapD available at the beginning for doing data prep, data discovery, doing some of the initial modeling, especially the feature engineering piece. Then we went out using the GPU data frame. We made that data available to H2O AI in this case to do the modeling, to do the prediction, and then bring the data back into MapD so we can visualize the results and do black box modeling against that result to see how accurate it was. And what we wanted to do was see, okay, does it make sense for us to have this kind of transition between these tools and have these different personas involved at different steps in the process? So, more demo time. Okay. Wrong way, this way. This is about 2 million records of churn data from Volkswagen for a country that I cannot name. They took all the cars in that country and they broke them down by probably 30 different variables. And then they tried to predict which of those customers was most likely to churn, most likely to not buy a Volkswagen next time around. So this is a pretty well understood problem, so it's not like we're breaking new ground in terms of the problem we're trying to solve. But again, what we were trying to do was see how could these tools be used together to be able to answer some of those questions. So the first thing we did was we brought the data into MapD. We built some pretty simple charts to be able to see kind of, okay, do some feature engineering and find out, what are the correlations between things like churn by mileage. Probably no surprise that as you put more miles on the car, you're more likely to trade it in. Interesting to see that certain car varieties, certain car brands, the more you kept it, the less likely you were to churn. You actually, you grew, no, I'm sorry, that's what it says. This says the longer the car was in the market, the less likely it was for those customers to churn from that car. So the first year of this car, not so good, not so good, not so good. But over time, they started manufacturing that car more better. They started marketing the car better. They started finding better customers for it. And over time, it became less and less of a churn problem. This was the first step. The first step was to do this kind of feature engineering, take a look at the sort of correlations between the different features. I'll just give one quick example. This poor car, and I'm not going to tell you which one it is, started out with a terrible churn rate. Like early on, even though you had very few miles on that car, people were very likely to turn that car in and buy a new car, which was really surprising and not very good news for Volkswagen. But this is the kind of thing that they were looking for. You can see they split the data up into test and train models. Probably no surprise there. I think everybody that's probably done this before has seen that happen. Then they switched over to Python and started doing the actual predictions. So importing all of their necessary libraries. You can see PyMapD, you can see PyGDF here. The first thing they did was actually make the connection to the MapD database and then fetch all of the data into these GPU data frames. So now they're actually pulling the data into GPU data frames, and they can start the pre-processing, and then away they go with the training. It's a little bit further down here. They had more pre-processing than usual. They define the hyperparameters, do the training. This workbook is available for anybody that wants to play with it and follow along. I'm going to give you a link to it in just a second. I can't give you the data, unfortunately, because it's proprietary Volkswagen data. But I would love to work with you to take similar data you might have and be able to sort of rework the script to be able to run against your data and be able to create the same kind of an experience. What Volkswagen did then was they brought that data back into MapD so that they could see the actual results, the partial dependency plots, the actual results of, okay, which of those features mattered. And they started to then train their model against those features. Okay, I'm down to 2 minutes. I apologize. Here's where you can get those examples that I just showed. So this is that Python script is available there. Again, all these slides are available on Speaker Deck, but please, I'll stick my head in like this. Next steps. Okay, so first of all, the room is packed and it's 100 degrees in here, so that's a good sign. But I can tell everybody is super excited about MapD. Yeah? Okay, no giggles. Come on, don't giggle. Okay, so if you're super excited about MapD, here's what you can do tonight to start playing around with it. First of all, go play with the demos that I showed. We've got those plus a bunch of other ones. There's a really cool one with NBA stats going back dozens of years. You can see kind of who's the best shooter. You can limit it to certain parts of the court. It's pretty interesting stuff. Second is, if you want to get an instance of MapD running on GPU in 90 seconds, you can go to mapd.cloud and spin up one of our software as a service instances for free for 14 days. Upload your own data into it, play with it. It's a single GPU, but it'll still take millions and millions of rows. So go play with it. We have 3 sample data sets in your trial instance of cloud that you can play with, or you can upload your own. But that's the fastest way to get your hands on MapD. Just go use our software as a service version at mapd.cloud. If you say, no, but I've got all these GPUs and I want to run it in my environment, great. Go download our community edition. It includes everything you've seen here, and you can run it anywhere you like. It's for non-commercial use, so it's designed to be used by community members, but it'll get you up and running, get you started. And last but not least, we have a pretty active forum. If you go to our community forum, all of our engineers are there. So if you have any questions or you're running into any problems, don't be shy. come join us on the community, and I'll be happy to make sure that you get all the answers that you need. And with that, I got time for one question, I think. What do you think? One question? One question. better be a good one. Yeah, you're going to have a good question, I can tell.
Can you render all this into movies?
Great question, actually. Can we render these into movies? So because the query time is so fast, you can make it feel like an animation. I wouldn't call it a movie. So Harvard, we've been working with Harvard. They took the National Water Model, which is basically a bunch of predictions about floods that covers the entire US. Huge, huge data set. They took the entire National Water Model, brought it up into MapD, and then we could create animations that would show how the water would flow based on their prediction out from specific storms out to the oceans. That's cool. And we could do that using animation, and it made it feel, there again, more interactive, right? I wouldn't call that a movie yet, because we're still talking about, on the fast side, 200 millisecond query times. But that certainly feels like an animation. So if you want to do something faster than that, come talk to me, because I'd love to talk about it. I will say one other thing. We took a bunch of LiDAR data, hundreds of millions of points of LiDAR data, which, as you know, can be very, very big. Hundreds of millions of points of LiDAR data, brought them into MapD, and rendered them using our 2D renderer, and then built a custom app rendering them using 3D. And so going back to your point about making it interactive, making it feel like a movie, when you've got 3D LiDAR points that are being rendered from a MapD database where you can kind of interact with them, zoom in, zoom out, through the valleys, it starts to feel like something that is really interactive, a really unique experience. That was built by our brilliant summer intern, Dipti Kothari, who's actually here in the front row. She's a USC student, yeah? So next year, she's going to come back here and do all the super awesome demos, and I'm going to sit out in the audience and just go like this. So, does that answer the question? Yeah. All right. Unfortunately, I've got to cut it there, but I'll stay here as long as y'all have questions, and I'm happy to go out in the hallway too. I've got business cards if anybody wants to contact me. I've got MapD stickers. Every laptop's leaving here with a MapD sticker, so you might as well put it on yourself, because otherwise I'm going to put it someplace you don't want. So come up and get a sticker, get my business card if you want to contact me, or any questions you have. Thanks, everybody. No, just spin it up in AWS. They've got 100 of them. Yeah, they'll be happy. You can. The smallest one they have, which has a single GPU, is I want to get this right, 19 cents an hour.
Okay.
So it's pretty cheap. I mean, it's not cheap, but it's cheap enough.
Okay. So we can just use your